As a first topic in digital system design, we are going to discuss about introduction to digital electronics. First, what is meant by digital electronics? Digital electronics is a branch of electronics that is used by discrete signals that uses binary numbers as zeros and ones. It uses the fundamental blocks like logic gates and or not and is used for modern computing, telecommunication, and automated systems. So, digital electronics deals with the discrete signals like zeros and ones. If the value is high, the value is high, it is 1. If the value is low, then it is 0. The basic blocks of the digital systems are logic gates, combinational circuits, and sequential circuits. First, logic gates. There are AND gate, OR gate, NOT gate. It takes the decision based on their inputs. So the output depends only on the present input. In the diagram, OR gate, NOR gate, and NAND, XOR, XNOR, buffer, and NOT gate are shown. Next, combinational circuits. In the combinational circuits, the output depends only on the present input. For example, adders and multiplexers. So, this is the block diagram of the combinational logic circuit. Here, the output depends only on the present input. Next, sequential circuits. Here, the output depends on both present input and previous output. So, in the diagram, it uses the memory as feedback and it also uses the clock signal to generate the output. Example, flip-flops, registers and counters. Next, what is the difference between analog and digital signal? Here, it is shown in the analog signal, the waveform is a continuous waveform. But in digital signal, it uses the values as already we discussed in the previous slide. It uses the values as zeros and ones. If the value is high, means 1. If the value is low, means 0. It uses only the binary values as zeros and ones. This is the basic difference between analog signal and digital signal. Next, advantages of digital electronics. The digital electronics is easy to design, it is very flexible to programming, immune to noise, it is used in high speed applications, it is a more secure data transmission. Then applications of digital electronics. In the application, it is used as robots to control the machines, then microchips, then in smartphones and also in the computers to store the device. What are the fundamentals of digital system? There are mainly two components. First one is number system, then Boolean algebra. The number system is a basically four types. Binary system with base 2, hexadecimal with base 16, octal with base 8 and decimal with base 10. It is used to simplify the binary operations for the programmers and also the system engineers. In the Boolean algebra, it is a mathematical framework which is used to simplify the digital circuits. It mainly uses the technique called K-map, which reduces the complex logic functions into simple forms. Next one is number system. So number system has basically four types as already we have discussed. Binary number system, base 2, octal binary number system with base 8, decimal number system with base 10, hexadecimal number system with base 16. These are the basic four number systems. First one is binary number system with base 2. Here it uses the only the digit values as zeros and ones and the radic value is 2. Here Already we have discussed in the binary values in the digital electronics basics. If the value is high, means the value is 1. Otherwise, the value is low, means the signal value is low, means the value is 0. For example, 1101 with base 2. This is an example for binary decimal system. So it uses only the 2-digit values, either 0, otherwise 1. This is the basic fundamental values which we are used in the digital electronics. Next, octal number system. In the octal number system, it uses the values from 0 to 7. The radix value is 8. Here it uses a 3-digit binary value. So, this system is used for the engineers, easy to read and write. For example, 245 with base 8. Next one is decimal number system. This decimal number system is a standard number system which we are using in our daily life. So, it uses the values from digits 0 to 9. It mainly used for the users for interfacing the input and output. It is not used in the computer process. It is used only for the humans to easy to understand the values. For example, 759 with the base 10. Next one is hexadecimal number system. The hexadecimal number system is widely used in microprocessors that uses the values from 0 to 9, and after 10 it takes the value from A to F. For example, the value is A, then A 10, B equal to 11, C equal to 12, D equal to 13, E equal to 14, F equal to 15. After 10 it uses the alpha values. This one is an alphanumeric value. For example, it uses the values from A to F. It mainly used for memory addressing and also for debugging. It also uses the 4-digit binary number representation. In octal, it uses a 3-digit binary representation, but in hexadecimal, a single digit uses the 4-digit binary representation. For example, 1A3 base 16. So, as a summary, what we have discussed in this class is, first thing is what is digital electronics, then what are all the basic building blocks, then what are the applications and what are the advantages, and mainly we have discussed about the 4 number system. So there are 4 number system: binary, decimal, hexadecimal and octal. Thank you.